So Danielle needs your help. She is practicing operations with polynomials, but she keeps making mistakes. Poor Danielle. Find the errors that Danielle made for each problem. Help Danielle understand her mistake by explaining the errors and then correctly performing the operation. So over here, she added x to the third plus 5x squared minus 7 and 5x to the third minus 3x plus 2x minus 1. So when your teacher went over this stuff back in like algebra 1, they were like, add, and you were like 1x cubed, 5x cubed. You would add those together and you would get what? 6x cubed. Why this girl put 6x to the 6th power? She added the exponents. So Danielle added the exponents. Yeah, she dumb. Okay, so for instance, like on the next part, you would have said 5x squared minus 3x squared, and that would have given you 2x squared. Homegirl put to the 4th power. Okay. Yeah. Danielle, she needs to go back to 1st grade. Okay. So on the next one, when she subtracted, okay, the first thing you do when you subtract, you're going to distribute that guy, right? Okay, so this would have been 8x squared plus 2x minus 6 minus 5x squared plus 3x minus 2. What did Danielle not do? No, look at what I wrote and what she wrote. What's different? That too. Okay, plus 2, and she put minus 3x. That means that she did not distribute this part. Yeah. So when you distribute, you got to share all the cookies. We are talking about polynomials. We're going to add, subtract, multiply these people, things. I'm going to get back to being able to talk soon. Add, subtract, multiply polynomials. Okay, back in the day. You ready? Okay, back in the day. This is what you learned back in algebra 1. Remember like the box method? Super cute, right? Okay. So when your teacher taught you the box method, they were like, you're going to take the first binomial and you're going to write it on the top. You're going to take the second binomial and write it on the side. And then you're going to multiply the sides, and that's going to give you 3x squared minus 5x, 18x, and then negative 30. And I'll give you a second to catch up because I know I'm talking. Once you filled in all those boxes, you're going to take all the stuff that's inside and write it out in one line. Okay. Yeah. And then you're going to combine your like terms. So what's 18 minus 5? 13x. Wow. And then bring everything else down. Okay. So what I want you to do is on this next one, I want you to try it. When we say x plus 2 and we square it, that's the same thing as saying x plus 2 times x plus 2. I want you to go ahead and try this second one. Multiply it out all the way to the end. Yeah. Okay, so when we multiply these together, we're going to get x squared, 2x, and then 4. We're going to take everything on the inside, and we're going to write it out. And then we're going to combine our like terms. We can add those two x's together. So that's going to give us x squared plus 4x. Y'all are so smart. Plus 4. And that's our final answer. Okay. Right. Okay. So now all we're going to do is we're going to add a trinomial to a binomial. We're multiplying those two. Okay. So all we did was we added an extra box. That's it. Notice how there were 2 by 2 boxes here. Now there's 3 by 2 here. So I'm going to take this first one and I'm going to write it up on the top. I'm going to take the second one and write it on the side. And now I'm going to multiply everything on the inside. Okay, so same thing that I did on the last one. All right. Okay, so on the inside, we're gonna get 6x to the third. What do you mean, what? 9, 10, 20. Okay, so where did the 3 come from? So here, pay attention. We got x squared right here, and we got x to the first right there. So x squared times x to the first, you're gonna add the exponent. Yeah. Okay. So on this next box, you're gonna take negative 4x and multiply it by 2x. And so that's gonna give us negative 8x squared. And we're gonna take 7 and multiply it by 2x, and that's gonna give us 14x. Okay, we're gonna repeat that process on the next row. We're gonna take negative 5 and multiply 3x squared. And negative 4x times negative 5. And 7 times negative 5. Okay, now what we're gonna do, instead of writing all this mess out again, there's a quicker way you can do this. You can actually add up your diagonals because they should have the same terms. Okay, so we're gonna go ahead and bring down this 6x cubed. And then we've got negative 15 minus 8, and that's gonna give us negative 23x squared. We got 20x plus 14x. That's going to give us 34x. And then we're just going to bring down that negative 35. Now, if you're not one of those, like, I want to add on the diagonal, there's too much going on, you can write it out and then combine like terms. That's okay. 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 So finding the perimeter and then finding the area of a rectangle, there's always one of these questions on there. There's always one of these kind of questions. Okay, sometimes it's like a simple expression and sometimes a little bit more complex. Think about perimeter. What does the word perimeter mean? Okay, so we're going to add up all the sides, right? Now they only list 2 of these sides. So that means that the one that's across from this guy is also going to be 2x minus 9. And the guy that's across, wow. The one that's across from this is also going to be x plus 5, right? And you told me perimeter means add up all sides, right? So I'm going to add up all of it. I'm going to say x plus 5 plus x plus 5 plus 2x minus 9 plus 2x minus 9. And then I'm going to take my handy-dandy pen and I'm going to combine my like terms. Everything that's in yellow, I'm going to add together. So 1 plus 1 plus 2 plus 2 is going to give me 6x. 5 plus 5 is going to give me 10. Minus 9 is 1. Minus 9 is negative 8. Voila. Okay, area. What does that mean? Multiply. So we're going to take these two things, we're going to multiply. So we're going to use the box. Okay. We're going to put x plus 5 on the top and 2x minus 9 on the bottom or on the side. We're going to multiply these together. You're going to get 2x squared, 10x, negative 9x, minus 45. I can't read my own handwriting. It's fine. Okay. When we combine like term, we're going to get 2x squared plus 1x minus 45. Okay. When you get one of these problems, I'm going to suggest something to you. Okay. First, check this first number and check this last number. Okay. When you multiply, you're actually multiplying like this, right? So that means that this last number over here is going to deal with this number and this number. What's negative 15 divided by 3? Negative 3. 5. I know for a fact that 5 has to go in this box. Okay. So right away, that's taken care of, right? Okay. Now, this first number is 12, right? So what two numbers can I multiply together to give me 12? 3 and 4. Okay, so let's try it. If I put 3 here and 4 here. Okay, so I'm going to multiply this out. So what's 3 times 4? That's 12x squared. 3x times 5 is going to give me 15x. Negative 3 times 4 is going to give me negative 12x. Negative 3 times 5 is going to give me negative 15. When I combine my like terms, that's going to give me 3x here. Is this going to work with what's going on over here?
No, because it's plus 3.
Okay, so what numbers do these need to change to in order to make this work?
Right.
Here, okay, there's a couple different answers for this one. Remember how it said any numbers? Okay, and we know that this guy's got to be positive, right? With like the numbers that we've already used. Why can't we just put a negative 3 in here? Okay, so you could leave a negative 3 in here, and then that would make this positive. Does that make sense? That's a way you could get around it. Now, if that didn't work, what numbers could we change this to in order to multiply them together to get 12? 12 and 1. Okay, so let's try that. If we put 12 here and 1 here, this was 5, right? Okay, when we distributed, we would get 12x squared plus 60x.
So the 1 would be the x.
1 would be here. Okay, so she put 1 here, 12 here. Gotcha. Okay, so Amy said we had to do it this way. Following what she said. So that's going to give us 5x minus 36x minus 15. When we simplify that, that's going to give us 12x squared minus 31x minus 15. I could put in a 31 right here. That would work as well. Okay, there's a couple different answers for that. Okay. Okay. Offers a variety of tile designs for customers to purchase. One of the rectangular floor tiles is shown below. For this particular tile, the customers can select varying sizes of the interior as long as it maintains a height-width ratio of 2:3. The tile has also the option of a trim border that is 2 centimeters wide, as shown in the diagram below. The company can determine the total perimeter and total area of any given tile by using this expression below, where X is represented in centimeters. Okay, this is where you would actually have to use math in flooring. They don't necessarily always do it this way, but you could do it this way. Okay, they normally use this expression to do like pricing. So, it's gonna be crazy. That's a little aggressive. Yeah. Okay, the Cinia is having trouble interpreting how the constants within each expression can be represented in a given scenario. Draw a model or write out an expression that explains this term. I want you to take a second, kind of read this back over and answer part A. Okay, so draw a model or write an expression that represent or explains this term. So what's going on here? Like, how did they come up with these expressions? Okay, where did this 2 to 3 go in our expression? 3x and the 2x, right? So this is talking about the height and width ratio. Okay. Now, where are these 4s coming from?
I think they might be width.
Okay. Just like what every standard tile would be, maybe. Because remember, okay. So 4 is the constant. It's a it always starts as a 4x4 tile. Does that make sense? Okay, so 4x4 tile, and then we kind of go out from there. Okay. All right, so we already talked about that 3x and the 2x, and it's talking about that height width ratio. Now, low-burn flooring needs to develop a simplified expression that can be used to determine the perimeter of any specified tile. Write an expression that represents the total perimeter of the tile with border and simplify. Okay. Go ahead and add that up. Just also want to remind you, the reason why this is a 4 is because look at what the trim of the border is. 2 and 2, right? What's 2 plus 2? John Jason, you're doing great. Okay, so if I was doing adding up this perimeter, that would give me 3x plus 4 plus 3x plus 4 plus 2x plus 4 plus 2x plus 4. And when I add all that mess together, what did I get? 10x plus 16.